the next 20 minutes, I will present you how we get from literally from nothing to pretty much we have a platform, we have a panel, and so we're ready to offering our clinical service. And disclosure, and I have no disclosures, and Beckman didn't pay my trip here. The only disclosure I have to give is all the product we use in this talk actually for research use only, not them being FDA approved. With that said, so Baptist Health, South Florida, actually dollars. I said $500 million, you can build a very nice football stadium. This is all you got. And so we think it's a proton therapy down the bottom that costs half of them. It's about $200 million. The institute opened in January 2017, but the genomic lab, we didn't move in until January 2018. If you remember, we had a hurricane last year in Miami, so that delayed a lot of construction. It's not so much the building damage because all the construction workers are from South American, so they all went home. It took them a long time to get. So I guess I don't have to talk too much about this, and we all realize what's happened in the last several years. And there are more targeted therapies, and there are more targets. And especially in 2017, and we all heard this, the Keytruda is being approved, and with MSI, and for all solid tumors. And both Foundation 1 and MSK Impact has went through the regulatory approval. And same as Oncomine was already approved at that time. And CMS also published their national coverage determinations for the NGS testing. And so with all this, within our system, we have 10 hospitals. We really didn't have a molecular diagnostic lab, so everything's been sent out. We send to all different reference labs because each oncologist have their flavors, and whether or not they understand the test, but they all have their flavors. So we have been sending to Foundation 1 and CARES Diagnostics, New Genomic for single gene testing, EGFR, KRAS, and BRAF. And also we're sending to MSK for our clinical trials because we, Miami Cancer Institute, we are a member of the MSK clinical alliances. And so because I guess there's a lot of connections between New York and South Florida. There's a lot of vacationers going down south. So at that time, we're trying to build a quote-unquote cancer genomic profiling program to support our patients. Probably we all remember this paper. Probably some members already also participated in this. And it's really to build a gene panel, to use a gene panel, probably with this study, it's about $1,900 with all things in, without indirect costs. So this is what I presented to the higher up. It's about $2,000 to produce a result. We just calculated ours right under this. It does cost close to $2,000. And I don't know, you has read this. There's a abstract at ASCO last year and calculated with hypostatic 1 million patient population for insure for the non-small cell lung cancer. You actually, if you bring using the NGS, you actually save money. And so with all this, this is what we presented to the Baptist Health. And the volume proposition to build a genomic medicine program. And because it's not, for us, it's not only for the cancer gene profiling, also we're building a biorepository facility at the time. And because our cancer patient mix are very unique, and over 50% of our patients are Hispanic in origin. And if you look at all the clinical trials, none of them have powers in this population. So our goal at this moment is we trying to consent all the patients with primary tumors. Also, we're asking them to give a tube of blood. And not only that, we're also establishing a quote-unquote normal population. And so we're consenting their relatives, and also their friends come with them for the clinical visits. We ask them to donate a tube of blood as well. So this is what we set out to do. And in phase 1, we were going to bring a panel online. We call them the MCM, Miami Cancer Institute Advantage, which is Illumina, the TST-170. We validated that panel. At the meantime, because of KEYTRUDA, we are going to bring on MSI with Promega. And also, because the EGFR need a quick turnaround time, we implemented a sample to result testing, which is ADALA. Probably a lot of them heard that last year. Of course, in phase 2, we're going to bring out, we also have heme malignancy service, and they always ask, what are you guys going to do for us? I said, well, you guys have to wait, just because the sheer number of solid tumors have a much higher volume. And so we built a little bit over 3,000 square feet lab space, and I have always worked in pathology in the hospital setting. We're always in the basement. But in Miami, there's no basement. And not only that, we lagged out. We are actually in the top floor, the corner of the building. And so also I didn't realize when you build a new cancer center, all your instruments is under the construction budget. I said, oh, great. They basically say, well, what do you need? I said, I need this, this. So you can see most of them I asked for, there's redundancy, except that NovaGene, the NovaSeq. They said, no, you have to justify your second one. We're not going to buy you 2 at the beginning. So it's there's a lot of powers as far for sequencing. And so at that time, this is what on the market. We did look, and when I first budgeted, I did budget S5 for thermal as well. And, but eventually our lab is not big enough to really maintain a 2 system, so we decided to go with Illumina. And so it's much easier to maintain. So we had a MySeq, NextSeq, and NovaSeq. And also we picked, at that time, the TST-170, because we look at the gene panels, and it's really, it fits the needs. And also they provide a lot of options besides SNVs and indels. And you can do fusion, CNVs, and structure changes as well. Lab is much easier actually now versus before. I'm always a guy trying to develop tests in the lab. And last 3 years, and it's very hard to do that anymore because the test is very expensive to validate. And so we always go out to look at what's available commercially. And also there's AMP, and with CAP and ASCO, there has published several guidelines. So it really make life much, much easier for us in the lab. So from the beginning, I set out, I said, we have to automate this because for manually doing the library prep, it's not an easy process. You can see we separate this in different components because, again, we're a small lab. We have about 14 FTEs. And So to do them all in-house is pretty difficult. So we decided at that time, I don't know, you guys heard the webinar, is that the CAB have their distributive models. So you can outsource part of your test or all of your tests and, for your NGS testing. So this is what we decided to do. We decided to do the web bench part in the lab, and we're going to use a outside service for our bioinformatic annotations. We choose Philips. There's several very good ones out there. Why we choose Philips at the beginning? Because I didn't realize how hard to go through a big corporation that like ours for contracting reviews. And take about 12 to 16 months to do a contract review. Actually, it took us over a year just to get the Illumina base space contract signed. And so we picked Philips because we already have a master contract in the health system, because we use a lot of their products for radiation oncology. And so we use theirs, then bring the report back, and the lab can sign it out. Basically, I will sign them out. And the first thing what we did is we went out to look at the extractions. And I'm familiar with Kaijin and Promega. That's what I used before in my previous lab. And at the meantime, my lab manager told me there's PharmaPure. I said, oh, what is PharmaPure? So it's, I believe, the AgentCore, right, the before. And so we all have used AgentCore products. And early on days, the whole genome sequencing, the AgentCore is part of that. And so we evaluated all this, actually, because we have some free time. We have 1 year before we are supposed to bring this online. And so we look at some of them with some of the samples with reference materials. And so you can see this is through the CE system, this is the PharmaPure. And so it generates a pretty good high, this is on the FIP reference materials, generate pretty good peak on the high molecular weight. High molecular weight in this case is relative. High molecular weight in this case is relative. And besides that, also remember I said this is the workflow is not really for manual extraction. So we went out to look at what we can have as far as automations. And if you guys went to the Illumina website, actually there's recommendations out there. And so I have previously used the Biomac in my previous lab. So we went out, so I said, we'll see what's available as a Biomac. At that moment, their I-Series just came out. After all, I always said, I'm still a toy guy. I said, let's get the new ones. So there's i5, there's i7. i7 is a little bit overkill for a hospital-based lab, so we picked i5. And so we mapped, at the same time, we mapped the true library prep workflow. We have actually in the corporate, we have a group just doing this. That's all their job. They go to different part of the hospital, different clinics to map their workflows. This is what they come out with. And I said it's not for faint at heart. It's a long process. And but with that said, our lab manager actually, she did the first time manually. It worked beautifully. And I said, she said, oh yeah, we can use hands. I said, no, let's not do hands. Let's do machines. So with that, we set out to get this automation to work. Took us a while. We hired a guy. Because why we went to the automation? Because it's very hard to find molecular tags, especially in South Florida. People there just do not have, I had a hard time to recruit tags working in the lab. But I was lucky enough, I had a guy, he has worked with Hamilton before, so he's really a toy guy. He literally sit in front of the I-5 for days to look at which step should be changed, which step works. Because remember, there's enzymes on the deck, and so we're trying to shrink the process time as little as we can, because also some of the pipetting for the enzymes, they are very viscous, and you need a slow pipetting. That's some of the things we never thought about until we sit there and to literally watch every single step. We have the door open. Anytime you want to stop, you just put your hands in there, the whole thing stopped, and then you can restart. So we adjust it, and so eventually with Beckman's help, because they have to program it, we made a lot of suggestions, and we test a lot of different plates on the machine. Because some of the PCR plates, they are not hard enough. They're too soft. So when the tip coming down, the plate actually moves. So we test several different plates, and we found what we liked. So I list two underneath, probably you cannot see. Like I said, you have a question, talk to me afterwards. So eventually we get this thing working, and work beautifully. With this whole process, we also, like I said, remember we picked Philips, and they call it IntelliSpace Genomics, with the annotation, with bioinformatic process and annotation. And N of 1 actually is embedded in the Philips ISG program, so they are part of it. So this is our very first run on the machine, and mostly they're reference material with Genome in the bottle, and TheraCare and Horizon. And you can see the coverage is pretty good as far as the amount of read being generated. The one thing we found, actually, I need to go talk to Horizon. Horizon samples in our hands consistently generate twice or even 3 times reads. Don't know why. I'm wondering whether or not there are other materials being mixed in there. And so compare with Genome in the bottle, even compare with TheraCare. So if you use that reference material, so in our hands, I say, are you artificially inflate your detection limit? So that's why we decided now to use that to establish the detection limit. So this is our clinical samples, our validation. I do not have a lot of data, but here just give you a flavor. And so this is how the panel covers, and the mean coverage with each clinical samples. Actually work in our hands beautifully. And we have a very good coverage. On average, we have about 1,500x coverage. And this is just another way to display and the coverage with the reference materials with our FFP validation samples. And so eventually we decided to use 250x as our cutoff. So we can reliably detect about 4 to 5% SNVs and indels. You can see the first line coming drop very quickly. That is the no template control. And we use TheraCare to establish our detection limit because in that trial level TheraCare, there's a 4% SNV levels. And so you can easily establish your detection limit. And because in our hands, when we dilute that 1 to 1, the bottom picture, you can see some the SNPs or SNV, the mutations disappeared. But we can reliably detect about 4%. So this is what we got. And we used NextSeq 550. And the input DNA in our hands is about 80 nanogram we tried, and the 40 nanogram works well for some of the samples. And take us about 3 days. Illumina will say take 2 days for library prep, but take us 3 days because the second day, you can get it done in 2 days, but the second day just a little bit longer. And so we're still trying to figure out, do we have a long shift or not? We can run 8 DNA, 8 RNA on each run, or if you only run DNA, you can run 10 or maybe even 11 probably. And we have 99% coverage for 250X, and we can reliably detect 4% allele fractions in the SNVs. And so I think my time is up. I'm going to go through this pretty quickly. And so this is overall to look at the assays. It's really the sensitivity and specificity is probably over 99%. And so far we have validated 64 samples. So our goal is to above 110. We have the samples already all extracted. And so far we have 100% concordance with the reference lab testing. And this is just a reference material for fusions and for splice variants, and we pick them all up from the reference material. We have very little clinical samples. So that's where we send out to other labs. I said, please help with our validation samples. So people are very generous. Internal challenge to bring this on in our system is really the administrative part. I never thought about it because we're an independent lab and we have our own CLIA and CAP in the system. And the most challenging part for us actually is a contract review. And this part, probably you all know, and it's really the physicians, especially the oncologists, play a big part in this implementation. They have the buy-in. Took me a while. When I first got there, I said, okay, I will do a 26 gene Illumina, maybe 50. Would be good enough for a community cancer center. So I announced that to them. They said, oh, no. I said, what do you mean? They said, we send to Foundation. They have 300-some genes. We send to Caris. They have 600-some genes. Your 50 gene, no, we're not going to use it. I said, what do you mean you're not going to use it? I said, I think 50 genes is overkill for what you're doing. But still, I couldn't convince that, so I have to go out to find a gene over 100. I said, you're happy? They're 3 digits. So it's oncologists, they have their own mindsets, and you have to convince them that. And you need administrative support. And IT is another big part. It's whether or not you can get to the cloud. And for us, it took a while to get to base space even. And most of the health system, that's their first thing they will say, no, you cannot go anywhere. And in my previous lab, we actually built our servers outside our hospital firewall. We call them in the DMZ. And there, I said, okay, we're outside the wall. You're happy now? So, but this part, actually, we convinced them. They looked, and eventually they let us go to the cloud. So that makes our life much, much easier. I think I'm going to go this very quickly. The importance to have an in-house expert. This is a test from a reference lab. They picked up, it's a lung cancer, small cell lung cancer, the diagnostic sample, the primary tumor. They picked up an N of 1. And I do not know their mistake. I'm still trying to get hold with them. Or they're put on there. So they recommended FDA-approved therapy, which is not true. Here's the FDA-approved, the product insert. It's really for BRAF. Yes, there are clinical trials. There are 1 phase 2 trials on there. And the scary part for this is, as a community oncologist, if they really just take that report as what it is, they're going to treat the patient with it. So We have our tumor boards. We have all site tumor boards and the molecular tumor board. And I had an oncologist ask me, said, "Gee, forget setting your labs. Just work with us. We can send everything out. You can just go review all the reports what they send back." And so the in-house expertise is very important. So you can hold oncologists' hands. You can tell them what's true, especially in the recommendations. You really, if you're carefully looking at the big reference lab reports, they literally put everything on there. You have to really critically looking at the reports and looking at the patients and work with your oncologist. And to really, this is to benefit our patients. And so, again, it's nothing you guys don't know, and this is just our story, how we got there from the beginning. Took us about 8 months. We didn't validate the fusions for the ALK and ROS, because at this moment, the fish is still, I haven't found a lab really using the next gene to replace the fish for ALK and ROS. So we decided not to offer that part. We were going to do this on a research basis for the fusions. And we will decide whether or not we're going to validate it for clinical use, or we're just going to do a rolling validation for that part. Well, thank you for your attention. And if you need to talk to me, I will be here after this. I think that'll be it.